transistor. Metal oxide semiconductor field effect transistor. It is also called as IGFET. IGFET, insulated gate field effect transistor. Insulated gate field effect transistor, or insulated gate transistor, or insulated gate transistor. Okay, right? So it is a metal oxide semiconductor field effect transistor. Right, it is same as it is complete opposite of JFET, complete opposite working of JFET. Okay, so MOSFET is nothing but metal oxide semiconductor field effect transistor. IGFET is also known as IGFET, and it is also known as insulated gate transistor, IGT. Insulated gate transistor, insulated gate field effect transistor, and MOSFET, metal oxide semiconductor field effect transistor. Okay, so this MOSFET is going to use in many applications, many circuit applications such as digital communications and digital electronics, and sometimes it is also used as a memory elements. Memory storage devices. Okay, so it is also having a same terminals. Terminals are gate, drain, and source. GDS, gate, drain, source, and as well as substrate. In FET also we have substrate, but is negligible. In JFET also we have substrate. But that is negligible. Gate lo kuda, JFET lo kuda manaki substrate untundi, but then manam consider chesko. Here also we have substrate, gate, drain, and source. Gate, drain, and source. Okay, so we have the construction. Regarding this MOSFET, and it is drain, and it is substrate, and it is p-type material. Substrate, and it is source, and it is n-type material. And this is gate. So we have the insulation layer atla itla vastundani tarvata chustam. Okay, so this MOSFET also having two types: N-channel enhancement mode and depletion mode. And enhancement, again we have two types: P-channel and N-channel. And depletion, again two types: N-channel and P-channel. Okay, so in this MOSFET, and it is drain, and it is source, substrate. It is a P material, it is N, and it is also N. Okay, so what we have to achieve here? Gate. Okay, so we need to create the path in between these two, drain and source. Okay, so in JFET we have already path, but we are controlling the path in a JFET. Okay, so ikkada enti source to drain madhyalo enti, so we need to create a path. In between drain and source. Ade JFET lo aithe already path untundi, మనం ఏం చేయాలి, దాన్ని కంట్రోల్ చేసుకోవాలి. Okay, so here we don't have path. Here in MOSFET we don't have path, just we are going to create one path in between source and drain. Okay, so ఇక్కడ నుంచి ఇక్కడికి మనం ఒక path ని క్రియేట్ చేసుకుంటే అక్కడ, so there is a conduction between source to drain. Okay, so if there is any conduction between source to drain, and that MOSFET is working. Okay, and this is the layer. Here this is the layer. Okay, so this layer is working as a plate capacitor. This layer is called working as a plate capacitor. So this layer is made up of with a silicon dioxide. Silicon dioxide, SiO2. Okay, so this layer is made up of with a silicon dioxide, and it is act as a plate capacitor. It is act as a plate capacitors. By using this plate capacitors, so we are going to create one path between source to drain. Source to drain or drain to source. Okay, so here we are applying the negative voltage to the gate. Here we are applying the negative voltage to the gate, and the negative voltage is nothing but the electrons. Negative electrons is applied at the gate, and this after applying this gate, so capacitor. What is the function of capacitor? Function of capacitor is a charge the electrons. Charge the electrons and at a certain time, and that is going to discharge the electrons. Discharge the electrons in a outputs. And ఇక్కడ నుంచి charge చేసుకుంటున్నాయి. So at the input side, it is going to charge, and after that discharging to the this region. ఇక్కడ charge చేసుకున్న తర్వాత ఇది full అయిన తర్వాత ఇట్స్ లైక్ ఏ వాటర్ ట్యాంక్. ఓకే, ఫుల్ అయిన తర్వాత బయటికి ఓవర్ఫ్లో అవుతుంది. ఓవర్ఫ్లో అయిపోయిన తర్వాత సో ఇవంతా కలిసి ఇక్కడ నుంచి ఇక్కడికి కండక్టివిటీని ఫామ్ చేస్తుంది. Okay, so this is the MOSFET construction, and this is a SiO2 layer, and gate, drain, source, and substrate. Okay, so here we don't have any work with the substrate. ఇక్కడ మనకు substrate దగ్గర ఎలాంటి వర్క్ లేదు. Okay, so it is a P type substrate. అక్కడ కనిపిస్తుంది అంటే just for graphical representation, right? So gate and SiO2 layer. So SiO2 layer, that is the insulator. Silicon dioxide layer, it is a insulator. So insulator, what is the function of insulator? What is the function of insulator? Insulator. What is the function of insulator? How the insulator behave? How the insulator behave? ఉన్నారా ఎవరైనా?
సార్
ఆన్సర్ తెలియకపోతే బయటికి వెళ్ళిపోండి. ఆన్సర్ చెప్పకుంటే మీరు అవసరం లేదు నాకు ఉండేందుకు ఇక్కడ. తెలిసినా తెలియకుండా కానీ ఒకటి రెస్పాన్స్ అనేది ఉండాలి.
తెలియదు సార్.
ఇంకెవరికి తెలియదా? నోట్స్ ఓపెన్ చేయండి. కొంచెం నోట్స్ ఓపెన్ చేస్తే అక్కడ ఫస్ట్ టాపిక్ ఏదో ఉంటుంది, సెమీ కండక్టర్స్, ఇన్సులేటర్స్ అని. దానిలో చూస్తే మొత్తం తెలుస్తుంది. What is the example for insulators? అయిపోయింది.